Hello everyone, I'm Guru Prasad. Today we are going to explain about some of the most important topics related to DMS, that is discrete mathematical structure. The topic name is the additive group of integers modulo n. So let's begin the presentation. So first we'll move on to the introduction. Introduction to additive group of integer modulo n. The additive group of integers modulo n, denoted as Zn, consists of integers from 0 to n minus 0 to n minus 1. This group operates under addition modulo n, where the result is always within the range of 0 to n minus 1, and the Zn forms a cyclic group with the n elements. So this is how the additive group of the integers modulo n works. So this is all about the denotations of the terminologies. So next we'll move on to the properties. Properties of the additive group of integers modulo n. The closure property. The sum of any two elements in the Zn will be always result in the group of another elements in the Zn. So the next one is the associative property. The addition in the Zn is associative, meaning a plus b a of a plus b of plus c is equals to a plus of b plus c for all a b c in the Zn, that is additive group. The identity element, that is, or the identity property, the identity element in Zn is 0, where a plus 0 is equal to a for all a is equal in the Zn. So the property and the operations are given in the picture. So the commutative property will be in the addition, a plus b is equal to b plus a. Subtraction, a minus b is not equal to b minus a. Multiplication, a into b is equal to b into a. And the division, a by b but not equal to b by a. The distributive property will be a into b plus c, or a of b plus c is equals to ab plus ac. In the subtraction, a into b, or a of b minus c is equals to ab minus ac. And the multiplication and the division, the distributive property will not be applicable. So the identity property in the addition, a plus 0 is equal to 0, and the 0 plus a is equals to a. In the subtraction, it won't apply for the identity property, is not applied for the subtraction. For the multiplication, 1 into a is equal to a into 1 is equals to a. That is all about the multiplication operation related to identity property. So next we'll move on to the inverse element in the additive group of integers modulo n. And every element A in Zn has the inverse element in the B, such that a plus b is equals to 0 mod of n. This is the general form. So the inverse of the element A is denoted as a minus of a, where a plus of minus a is equals to 0 of mod n. In additive group, that is Zn, each element has the unique inverse element. So the next topic will be subgroup structure of the additive group of integer modulo n. Zn consists of subgroup of different orders, including the trivial subgroups and the entire group Zn itself. The subgroup of Zn are closed under the addition modulo n and form a group of under the same operations. And the order of subgroup D must be divided the order of the group of n, which will be denoted as a D by n, or the D or n. So D line, or the D divided by n, will be the denotation of the subgroup must be divided order of the group of n. So the order of the group will be n, and the subgroup D must be divide the all the elements which is present in a group n. So next we'll move on to the generation or the generators in the additive group of integer modulo n. The an element G is Zn is given as a generator if the set G2, G3, G up to n minus 1 of G covers all the elements in the Zn. If G is generator of the Zn, and then Zn is a cyclic group of the generated by the G, the number of generators in the Zn is given by the Euler's totient functions phi of n. So this is one of the example which is shown in the figure. So the in the figure, the in the example, the number of what is that, the n is equals to 5. So the 18, for example, 18 is equal to minus 7 of mod of n, and all the elements which will be divided like d by n, like denoted as the subgroup D must be divided the order of the group n. So this is how the that formula will work with the help of example. So next we'll move on to the applications. Applications of the additive group of integers modulo n. Zn is a fundamental in the cryptography, particularly in the field of public key encryption. Modular arithmetic based on a Zn is used to computer science for the hashing and the error detection or the corrections. And Zn is also utilized in a various algorithms such as the Euclidean algorithm and the Chinese remainder theorem. that is CRT. So the next group, isomorphism in the additive group of integers modulo n. The two groups Zn plus and the Zm plus are isomorphic if there exists bijective homomorphism between them, and Zn and Zm are isomorphic if and only if n and m are co-prime, denoted as a GCD of n comma m is equals to 1. Isomorphic groups have the same group of structures and despite having the different elements. So it will follow the all the properties of the integers, which will be like the closure property, commutative property, associative property, distributive property, and the identity property. So this is how the isomorphism will be work in the additive with the help of additive group of integers for the modulo n. So next we'll move on to the order of elements in the additive group of integers modulo n. The order of element in the Zn, order of element A in Zn is the smallest positive integer k such that Ka is equals to Ka is logically equivalent to 0 of or O of mod of n. The order of an element is divides the order of the group such that order of A is divides the n for all A in the Zn. That means the order of A will divides all the elements which will be present in the Zn. So the elements with the maximum order of the n are called as a primitive elements in the Zn. So the order of n of A is equals to k. If k is the smallest state of the AK is equals to 1, then 1 of mod of n. So this is a general form. Next, we'll move on to the direct property or the direct product of the additive group of modulo n. The direct product of the two additive groups Zn and Zm is denoted as a Zn into Zm. So the elements in the Zn and the Zm are pairs A, comma B, where A is a Zn and a B is a Zm, with addition defined component wise. The order of Zn cross or the order of Zn into Zm is the product. Zn cross Zm is the product of the orders of Zn and Zm such that the modulus of or the order of Zn cross Zm is equals to order of Zn into or the cross product or the order of Zm. So the direct product rules will be G cross G is equals to G, G cross U is equals to U cross G is equals to U cross U is equals to G, and A cross A is equals to A cross B is equals to B cross A is equals to B, and B cross B is equals to A. So this is the direct product of the additive group of the modulo n. So next, the major factors of the group in additive group of integers modulo n. A factor group, also known as a quotient group, is formed up partitioning a group into the cosets of the subgroup. In Zn, the additive group, the factor groups are constructed by the dividing the Zn into the cosets of the subgroup dz, where d divides n. And the factor group provides the insights into the group structure and are used to various mathematical applications. So next we'll move on to the applications of the additive group of integers modulo in the coding theory. In a coding theory, Zn is used to define a linear block codes that correct the errors in the data transmission. Error correcting codes based on the Zn ensures reliable communication by detecting and correcting the errors. The properties of the Zn, such as closure and the inverses, play the crucial role in the designing the efficient error correcting codes. So this is where the additive group of the integers can be used. So the major factor, that is the challenges and the future of the additive group of integers of the modulo n. The first one is the exploring the computational complexity of the operations in the Zn or in the additive groups for the large values of the n for the challenges, and a research on applying the Zden's quantum computing and cryptographic protocols is a promising area for the future study. Enhancing the efficiency and the security for of the algorithm based on the additive groups, that is denoted as Zn, remains a focus for the advancement in the field. So the final conclusion for the additive group of the integers modulo n is the foundational concept. It is a foundational concept in the algebra and the number theory, and it will be also used in a code theory also. The Zn exhibits the various properties including closure, inverse, and the subgroup structures, making the essential in the diverse mathematical applications. And the final one is the understanding the Zn or understanding the additive property, additive groups of the integers of the modulo n and its properties provides the insights into the group theory and the cryptography, the coding theory, and the computational algorithms. So this is where the all the applications and the introduction and all about the additive group of the integers of the modulo n. So this is all about the additive group of the modulo n. So I hope you guys enjoy this video. Please like, share, subscribe the video. So thank you.